There's a material that costs less than $1 per linear foot. You wrap it around your noisy pipes, and the banging stops. The hydraulic hammering that shakes your walls every time you shut off a faucet. The vibration that travels through your ceiling when the dishwasher finishes a cycle. The rhythmic ticking of pipes expanding against framing. All of it gone. Permanently. No jackhammer, no wall demolition, no replumbing. No plumber standing in your living room giving you a $4,000 quote to access pipes that should never have been making noise in the first place. Water pipe noise is one of the most common homeowner complaints in residential housing. It is also one of the most misdiagnosed. Plumbers bill it as a pressure problem requiring pressure reducers. They bill it as an air hammer requiring air chamber installation. They bill it as a pipe support problem requiring wall access. And every one of those diagnoses generates a service call, a parts list, and an invoice, when, in the majority of cases, the noise is caused by vibration, physical vibration of the pipe against whatever solid surface it contacts. And vibration can be silenced with a $1 piece of foam. Then someone in a corporate boardroom did the math. The plumbing services industry in the United States generates over $130 billion annually. Pipe noise diagnosis and repair is a recurring revenue category. A $4,000 pipe access and resupport job is not unusual for a problem that $5 of pipe insulation foam and 4 nylon cable ties eliminates permanently. And what eliminates a $4,000 service call must be kept off the homeowner's radar. Welcome to Forbidden Fix. If these stories matter to you, hit subscribe and the bell. This is where we dig up what industries spent decades trying to erase. To fix pipe noise permanently, you need to understand exactly what creates it. And there are 3 distinct mechanisms, each with its own solution. The first and loudest is water hammer, also called hydraulic shock. When you close a faucet or a valve quickly, you stop the flow of water abruptly. Water is heavy. A column of water moving through a pipe at several feet per second has significant momentum. When a valve closes and that momentum is suddenly interrupted, the kinetic energy has to go somewhere. It converts to a pressure wave. That pressure wave travels backward through the pipe at the speed of sound in water, which is approximately 4,800 feet per second. When it hits a rigid boundary, a closed valve, a fitting, or a change in pipe direction, it reflects back. Then it bounces forward again. This bouncing pressure wave slams the pipe against whatever surface it contacts. You hear it as a single loud bang or as a rhythmic hammering. It can be violent enough to eventually crack pipe joints or loosen fittings. The second mechanism is thermal expansion noise. Copper and CPVC pipe both expand significantly with temperature changes. Copper expands at a rate of approximately 0 to 0.094 inches per degree Fahrenheit per inch of pipe length. A 10-foot copper hot water supply pipe running between a water heater and a bathroom fixture can expand by over 1/4 of an inch when transitioning from cold to hot water temperature. If that pipe passes through a hole in a framing member and the hole is tight, the expanding pipe grinds against the wood as it grows and contracts. The result is a rhythmic ticking or creaking that follows the temperature cycle of your hot water usage. The third mechanism is resonance vibration. Water flowing through pipes creates a pressure oscillation at specific flow rates. If this oscillation frequency matches the natural resonant frequency of the pipe, or the wall cavity it runs through, the pipe will vibrate at that frequency and radiate the vibration as sound into the building structure. This is the source of the continuous humming or buzzing that sometimes comes from pipes when a fixture is in use at a specific flow rate. All 3 mechanisms share a critical physical characteristic. They are all vibration. The water hammer is vibration. The thermal tick is vibration. The resonance hum is vibration. And vibration requires a rigid transmission path to become audible noise in your living space. Foam insulation eliminates the rigid path. Self-sealing pipe insulation foam is closed. Cell polyethylene foam in a tubular shape sized to fit copper, CPVC, and PEX pipe in standard residential diameters. It is slit longitudinally so you can snap it onto a pipe without cutting or unsoldering anything. When wrapped around a pipe, it performs 3 functions simultaneously. It adds mass to the pipe, which shifts its natural resonant frequency away from the excitation frequencies of typical water flow. It isolates the pipe surface from the rigid framing and supports its contacts, eliminating the rigid vibration transmission path. And it provides a cushioning layer that absorbs the pressure wave impact energy of water hammer, reducing the amplitude of the slam against building structure. For water hammer from high pressure or fast closing valves, adding a partial turn of restriction to the supply valve, feeding the problem fixture, reduces flow velocity and eliminates the pressure spike that causes the slam without meaningfully reducing the user experience. Before I go further, this video covers the primary solutions for the most common pipe noise scenarios. Inside the Forbidden Fix vault, I have compiled complete pipe noise diagnostic guides, pressure reducer installation procedures, air chamber and water hammer arrestor specifications, vibration isolation materials comparisons, and the full range of plumbing noise solutions from the simplest to the most complex. The link is in the description. But stay right here because the plumber's diagnostic process for pipe noise is the part that should concern every homeowner who has ever received a 4-figure pipe noise repair quote. The physics of acoustic vibration isolation have been understood by mechanical engineers for over a century. Every HVAC engineer who has ever designed a commercial building specification knows that pipe isolation is mandatory to prevent structure-borne noise. The American Society of Heating, Refrigerating, and Air Conditioning Engineers, ASHRAE, publishes detailed specifications for vibration isolation of mechanical systems, including plumbing. The Vibration Institute and the Acoustical Society of America both publish technical data on flexible isolation materials and their effectiveness. Building codes in Europe and in commercial construction in the United States typically require vibration isolation for plumbing systems. The same engineering knowledge applied to every commercial building is available to every homeowner for less than $5. It is simply never mentioned in the residential plumbing service context. The plumbing service industry's billing model does not accommodate quick, cheap solutions. A licensed plumber's minimum service call is typically between $100 and $200 before any work begins. Diagnosing pipe noise takes 30 minutes. The proper fix, foam insulation on exposed pipes, plus a slight valve restriction or commercial water hammer arrestor, takes another 30 to 60 minutes. The materials cost under $20. Total value delivered at a fair labor rate would be approximately $150 to $250. But the assessment of a pipe noise complaint often leads to recommendations for far more extensive work. Repiping, pressure regulation systems, air chamber installation, wall access to address interior pipe supports. These services generate invoices from $1,000 to $8,000 for problems that the foam and the valve turn resolve for $1. The escalation is not always dishonest. Sometimes the diagnosis is correct. But the initial intervention of foam insulation and valve adjustment is almost never attempted first, because attempting it first eliminates the justification for the larger quote. If you have made it this far, you understand more about hydraulic shock, acoustic isolation, and pipe vibration physics than 99% of homeowners who have been quoted $5,000 for a pipe noise problem that $1 of foam and 30 seconds at the shutoff valve will silence forever. Subscribe and share. Here is exactly how to do it. Step 1. Identify the location and trigger of the noise. Does it bang when a valve closes? Does it tick when hot water runs? Does it hum at a specific flow rate? The answer tells you which mechanism you are dealing with. Step 2. For exposed pipes making noise, wrap them with self-sealing pipe insulation foam. Press it onto the pipe along the entire run. Pay special attention to any point where the pipe contacts wood framing, metal hangers, or other solid structures. These contact points are the vibration transmission paths. Step 3. Replace any metal pipe hangers or clamps that contact the noisy pipe with nylon or rubber-lined hangers. Metal hangers transmit vibration directly into the framing. Nylon and rubber-lined hangers absorb it. Step 4. For water hammer. From fast-closing valves, locate the supply valve feeding the problem fixture. Turn it clockwise by approximately 1/4 to 1/2 turn, reducing flow velocity by 15 to 20%. This alone eliminates water hammer in most cases without any perceptible reduction in faucet performance. Step 5. For pipes inside walls. Making thermal expansion noise, identify the penetration points where the pipe passes through framing. At accessible points, open a small access panel or drill access holes at the top and bottom of the wall cavity. Inject expanding foam around the pipe at the framing contact to cushion the thermal movement. Step 6. Test after each intervention. Walk through the trigger motions. Turn faucets on and off. Run the dishwasher. The noise should be dramatically reduced or eliminated. Total cost, $1 to $5 for foam and nylon hangers. Compare that to the $3,000 pipe re-support quote. I need to be honest with you. The pipe foam and valve adjustment method resolves the vast majority of residential pipe noise complaints involving exposed or accessible pipes. For pipes that are entirely inside finished walls and inaccessible, access is required for any mechanical fix. In those cases, the partial valve restriction is the only non-invasive intervention available, and it resolves water hammer effectively but does not address thermal tick or resonance hum from interior pipes. If your water pressure is above 80 psi at the main, a pressure-reducing valve is genuinely needed and will resolve many noise issues as well as protecting appliances and fixtures from excess pressure damage. If water hammer is caused by a solenoid valve in a washing machine, dishwasher, or irrigation system closing instantaneously, a water hammer arrestor at the supply connection is the correct solution and costs between $15 and $30 at any hardware store. And if your pipe noise is accompanied by visible pipe movement, wet spots, or staining, the problem may extend beyond noise to a leak or a structural issue requiring professional assessment. Your grandfather's house never made these noises, not because the pipes were different, because they were run through walls with clearance, supported on rubber blocks, and installed by craftsmen who understood that a pipe in contact with framing is a noise generator by design. Then post-war housing construction accelerated and corners were cut. Pipes were run tight through framing holes. Metal clamps were screwed to metal framing. The physics were the same. The installation standards changed. Your house is not defective. It was built to a cost target that made noise an acceptable outcome. There was not a quieter construction method. There was just a more expensive one that got value engineered out. Subscribe and share. Every share preserves what they tried to erase. The next vault opens soon. And what is inside might add 3 years to your car battery using a material